Good morning. I'm Sandy Cashmark, Executive Director, extending a welcome from Tri-State Manufacturers Association and from Central Minnesota Manufacturers Association. In lieu of our typical face-to-face events and plant tours, my office has partnered with MPMA to bring you webinar content that's especially relevant for manufacturers during these unusual times. Thanks so much for joining us today for session 5 with a focus on 3D printing solutions.
All right, thanks, Sandy. Again, this is Steve Kalina, the President and CEO of the Minnesota Precision Manufacturing Association, or MPMA. One thing I covered more extensively last week, and I'm going to continue to recommend, was the recommendation to connect now with other similar businesses, as well as utilizing Medical Alley's Resource Connect and the Minnesota Chamber Supplier Match. With the numbers projected in Minnesota and the country, we must prepare for our labor forces to be drastically diminished with little or no notice. Whether you need resources or you need work, it's imperative to start the communication now and build those relationships so we can more easily shift production or resources on a moment's notice. I've included a link to a statement put out by the Department of Justice and Federal Trade Commission, basically acknowledging that competitors will have to work together during these times. They will still prosecute for clear cases of abuse, but will be more understanding of companies that are truly trying to work together for the good of the country. Today, the state legislators are voting on workers' comp coverage for first responders that contract COVID-19. Otherwise, they're continuing to work behind the scenes on further support, but no known votes that are going through in the next couple days here. There's still many questions over the SBA disaster and paycheck protection loans. I'll just say they're continuing to hammer out the details. You guys are probably seeing information daily on that. But banks have been submitting the applications for the paycheck protection feverishly, and of course, you may have heard that some banks are opting out of this program. It's also assumed that the Governor Walz will extend the current stay-at-home order, but that has not yet been declared. Just a reminder that you can find these webinar PowerPoints and recordings on MPMA and Tri-State's resource pages. You can also find other helpful information and resources that we've compiled. All right, now on to our main topic. Today, we're getting back to an operational topic and get to talk about what manufacturers love, which is technology. Matt Havicost of Advanced Tech, a Minnesota-based company that supports the Midwest in 3D printing solutions, will talk through how we can use 3D printing to solve operational and safety needs. When your supply chain struggles, when you're short on people, and when you need solutions fast, 3D printing can be an immediate solution to help you sustain operation. So I'm going to hand over controls now to Matt.
Hey, thank you so much, Steve. I appreciate you involving us, and our thanks to Minnesota Precision Manufacturing, as well as Tri-State. We are really excited to share some of this information today and look forward to future conversations as well. As Steve mentioned, the topic today, we want to talk about 3D printing solutions for operational needs. Just a quick introduction. I work for a company called Advanced Tech, and we've been providing 3D printing solutions for over 27 years now. It's been really exciting for me. I'm very passionate about this technology. I got to learn about it real early on in my career as a service technician, and I got to see that transition that happened when customers thought of 3D printing as a nice to have, and I got to watch that transition to where it was a need to have. And some of today's discussion, I hope you'll capture some of that, and that move from a want to a need, or a nice to have to a need. One of the interesting things about my start in 3D printing as well is I became passionate about it because my little sister Emily was disabled, and my parents used to use somebody who would fabricate things for her in order to be able to play with toys and different things like that. And it was immediate. It was an immediate awareness of how transitional, how capable 3D printing was to make something specific for my sister and her needs. And again, some of that will translate into some of the topics we talk about as well today. So let's go ahead and keep going here, the agenda. we're going to talk a little bit about how the coronavirus has affected manufacturing. We all know it's affected us in significant ways. There's probably some things that we don't know yet, but we do know that manufacturers have a constant pressure to optimize production lines, to scale up and scale down dynamically based on demand. We know that sometimes we need to retool. Sometimes we need to make sure that we mitigate any production challenges or downtime. And we know that this coronavirus thing is going to exaggerate all of those things. So let's see where. We know that it's gonna exaggerate all of those things. So the agenda today, we're gonna talk a little bit about the basics of 3D printing. We'll talk about how the supply chain has been affected a little bit and give an example of that. And then talk about how 3D printing, how we can maximize the 3D printing impact. Sometimes there's a lot of misconceptions out there about what the impact of 3D printing will be during this epidemic. And we wanna talk a little bit about how we can maximize the impact of 3D printing. And then we'll talk about some specific operational solutions that 3D printing can be used today. And then we'll follow up with some questions. So in terms of the basics of 3D printing, I'm not going to talk about technology as much, but in general, 3D printing starts with the CAD model, a 3D CAD model. That's a little different than traditional. We don't need to have drawings. It's just right from a three-dimensional CAD model. This means that we can design remotely. We can do what's called distributed manufacturing. We can send a file via email or other ways of transferring the file and be able to manufacture that part on site or remotely. Today, obviously, in today's environment of working remotely and social distancing, we've gotten lots of feedback from our customers in the past few days, talking about how great it is that they can manage and continue to work from home and be able to utilize the tools that they have. The second thing that is a part of all 3D printing technologies is that we're adding layers, right? Additive manufacturing, 3D printing, rapid prototyping. These are all referring to growing the part layer by layer. Most of you guys know that. Steve has reminded me that most of the people on here are pretty familiar with 3D printing. And I think it's important to note that we're not cutting, we're adding material, and that affects some principles that we'll talk about here moving ahead. And then the third thing that I wanted to make sure that we talk about as far as the basics of 3D printing is that it's really about the materials. Each technology is a little bit different, but they're all geared around specific materials. And the materials that we work with are thermoplastics, thermosets, and some metals. And it's real important because those materials lead to applications, and those applications are what become really powerful for our customers. So how is 3D printing different? 3D printing is different than traditional manufacturing because of that digital workflow we talked about. With Stratasys equipment, we use a product called GrabCAD Print that can manage the digital workflow. But more importantly than just the sending files to the devices or anything like that, the digital workflow allows us to produce parts without traditional hard tooling and gives us the ability to change designs on the fly, gives us the ability to iterate on the fly, and then it also gives us the ability to inventory parts digitally. The second thing is lights out production. This has really been game changing for us as a company because we can load up a machine. It doesn't have to be fixtured for one part at a time. We can batch print and load those overnight and spend most of the time remote while the printer is doing its thing and building the parts. Third thing is a concept that people talk a lot about: complexity being free. I put free in quotes because it's a little bit of a misnomer. What we mean by that is the additive technologies can produce complexity that traditional manufacturing may have a difficult time doing. So in traditional manufacturing, there might be multiple setups for added complexity. With 3D printing, it's a single setup. You can produce parts that are complex, that even have moving assemblies, and give us the ability to produce very complex geometry without much trouble, no added trouble. This is important especially for manufacturing applications when we can reduce part count, we can pull in multiple complex features and build it all as a single assembly for location and accuracy, and eliminate some of those stack up challenges. And then the other thing with complexity is it gives us design freedom. We can choose to print the part or the geometry that we need versus what we're limited to running or limited to getting a cutting tool into. And then the final thing is the most important. This is what I'm very passionate about here. Everybody that knows me that's on the line has probably heard me say direct access once or twice. But the accessibility of 3D printing is really what's been the game changer. Without direct access, the folks that are using 3D printing, it's a great tool, but they're not getting the real magic out of 3D printing. The magic comes when you have direct access in order to do development early on before you'd ever think of making a part. This is the value of 3D printing, is in the ability to design a part and print it. Whether it's a right design or a wrong design, you're learning something in the process. Many of our customers refer to it as failing faster or getting to the right design sooner. And then distributed manufacturing and sourcing is this accessibility, this idea of accessibility really illuminates the benefits of distributed manufacturing. Manufacturing a part where it's going to be used is very powerful, and disrupts the normal supply chain that we're used to with traditional manufacturing. And we'll talk about that a little bit in an example. One of the things that the coronavirus has caused is a challenge in supply chain. Everybody knows this, right? One of the biggest examples is in PPE. Most everybody is familiar with the PPE terminology now. But I thought I would share this example. This is just as an illustration of the power behind 3D printing. And this is just one example. It's an example that the industry has taken hold of. Some of that is because of media. Some of it is because of the enhanced and illuminated need right now. But the example of the face shield, I'm sure many of you have heard of it. But what's happening is there was a break in the supply chain where we weren't able to get, the hospitals didn't have face shields that they needed to protect themselves. There's a high demand, a high need. It's a well-known requirement. So as a stopgap measure, people started crowdsourcing designs for the visors that hold on to the plastic sheet that protect people, and they started distributing manufacturing. So this was a full crowdsourcing, kind of a true crowdsourcing opportunity where people at homes, businesses, even manufacturing companies of 3D printers were starting to produce these visors and distributing them locally to hospitals and healthcare providers. It was really exciting to see. They were able to fill a need quickly. I just read an article this morning from Seeking Alpha, and they called it a hyperlocal manufacturing turning on a dime to serve an immediate need. This is that's a very good description of what was going on here. Now the stopgap here is that this is not a high volume manufacturing method. It's low volume, high complexity. We're able to take these crowdsourcing designs and hone it in and get it approved in emergency purpose by the FDA. And they were able to do that very, very quickly because people were iterating on the fly. They weren't tied to a tool. They could distribute as needed. They could test, revise, move back, and get that approval that they needed. Very exciting project. And this is what the media has really taken on to. You'll see all kinds of news articles about this, probably see it in the news. But to me, this is not the most exciting thing about 3D printing. This isn't going to maximize the benefit. This is a stopgap measure, and it really illuminates some of the benefits of those principles that we talked about. But the real benefit is actually coming in maximizing it on the manufacturing floor, being able to use those same principles in order to support traditional manufacturing and to drive quicker change and to deal with all those new challenges that we have of making sure that we're flexible, making sure that we're safe, and all those new challenges that we have with COVID. So the challenges with traditional tooling are just like with the face mask. The tooling was expensive. It takes too long to get the tooling, high inventory costs. And when I talk about tooling, that's injection mold tooling in that particular case. These are all the same challenges that people experience on the manufacturing floor in terms of manufacturing support tooling, jigs, fixtures, things that are used in the process for developing a new manufacturing line. The factory floor has lots of different opportunities for 3D printing. In order to understand that fully, we want to look at the engineering group. We want to look at assembly and kitting, quality, painting, fabrication, shipping and receiving, and the tool shop. And 3D printing can fit into a lot of these different categories. I don't need to go through all of these today, but some of the standouts for me are in automation for the manufacturing and assembly line, in quality, fixturing and assembly tools, pretty much anything that's touching the geometry of the part that's being produced, or adding aid, sometimes we call them third hand fixtures, to support a process and to improve quality and those sorts of things. So lots of opportunities here. Let's drill down into a couple of specifics. If I can move the slide forward. Steve, I'm having a hard time moving the slide forward here. I don't know what, there we go. Okay, so 3D printing tooling, some specific examples here. Safety guarding, no-go-go gauges, assembly tools, nesting fixtures, automation end effectors, replacement or enhanced components. On the right here, there's some photos of some great examples. On the top is a safety guard for a drill press. This particular customer uses color to indicate warning or caution. They also put their logo on a lot of their parts. They're able to do this very easily and quickly in order to protect their workers. The other one is on the right top is a go no go gauge, basically a gap finder. We've got end of arm tools, nesting fixtures, and at the bottom there, that's a part for a local company that is making snowmobiles, and it's a cooling fixture. That part is about 16 components. It's very large. It was built in sections and then pieced together. But that particular part, as assembled, they built 3 of those, and those first 3 parts, the cost savings and the time savings, was the catalyst for paying for the initial investment in the equipment. So this stuff can be very cost effective, especially in comparison to traditional manufacturing methods. I'm going to play a short video here. The sound isn't going to be able to play, but basically what we're doing is we're showing how a traditional part is made out of aluminum. It's about 16 different pieces. 12 different components. Oops, sorry. So this is a traditionally manufactured part, solid aluminum. You've got to weld it all together. With additive manufacturing, we're consolidating that to 3 different components, and we're able to assemble that very, very quickly. The part is about half the weight. We're talking about days to produce a part, hours to produce a part. And optimizing the part to the operation. So these are some examples of part consolidation compared to traditional methods. And then a little bit more complex example is in automation tooling. Hopefully you'll be able to get to see some of this stuff. It's an earplug counting system. and they're going to highlight the parts that were 3D printed. So the whole idea behind this project was to reduce space and be able to produce the parts in organic shapes so that they could make the footprint of the automation equipment much smaller for their customer. These are some areas where they leverage the use of additive manufacturing. Pretty soon you'll see some yellow highlights. These are flow control valve mounts, nozzle mounting assemblies. This is the actual counting mechanism. The adapter on the bottom is a bayonet mount that they developed for quick change for the operators. On this machine, it's modular. So they've designed the tooling, the nesting, and the end effectors to be modular so that they can quick swap out for different size components. We're going to have links to these videos on the PDF for you guys. So if you weren't able to see much of it, or if it was glitchy, you can go back and take a look at that. I'd highly encourage you to do that. The customer does a very good job of explaining the impact that it's had on their business and on their customers. All right, so moving on to operational solutions with COVID-19 specifically. I've been talking to hundreds of customers here in the last couple of weeks about what they're doing and how they're mitigating the challenges. The number one item was, of course, worker safety. So many of our customers are producing customized PPE, personal protection equipment. They're providing workspace dividers, even in some cases, where they're printing the mounting mechanisms for separators so that they can deal with the new normal here. Facility layout plans was one I wasn't expecting. Because of the separation requirements, they're having to spread out their manufacturing facility and a lot of the assembly lines. So they've had to take over new space within the organization in order to spread out the workers. So some of our customers are producing facility layout plans in 3D to be able to map out the new changes and to do Kaizen studies on how the flow of the product is going to go through those new spaces. Lots of safety shrouds and color indicators for caution or for safety. Trying to limit the touch points for products was another thing that we heard a lot of. The second thing is continuous improvement. Some of our customers are ramped up even more because of demand for their products. Other ones are taking a temporary break. What a better time than any to do continuous improvement. So 5S tool organization, they're going to want to mitigate people sharing tools, being able to have organizational skills, organizational tooling to help manage that is a big value for the 3D printing. Space reduction, we talked about that a little bit with the automation equipment, but the space is becoming so critical because we have to spread out that we're trying to make the tools smaller in order to address that. I had one customer here locally who produced 4 different fixtures in a single cube in order to mitigate the space requirement for the assembly of a joystick. So each side of the cube had a process, step 1, step 2, step 3, step 4. Each side of the cube had a nesting fixture for the operation, and it kind of it acted as a way to manage the process, improve quality, but also reduce the space that was required for the workstation. The third thing is flexible retooling. So what do I mean by flexible retooling? Many customers are having to reinvent themselves. They're producing different products. We know that Medtronic just open sourced their ventilator product. We know that GM and Ford are both involved in reinventing their business right now to help with manufacturing ventilators. Digital inventory, quick change modular tools, and distributed manufacturing are key for these opportunities. And I'm going to call it an opportunity. It's also a challenge, but the ability to quick change tooling, to be able to use dual purpose tooling requires complexity. And that goes back to what we talked about with additive manufacturing being very capable of making complex tooling. The final thing I'm going to talk about is 3D printing and automation. Really, these two things are like peanut butter and jelly. They just go together. With automation, you require nesting, you require end effectors that pick the parts. Those two things interface with the part, and it's very easy and applicable to 3D print both of those and to reduce the footprint in the automation cells that are being integrated on the manufacturing floor. One side benefit that we get with 3D printing is that we can make lighter weight end effectors, which then allow you to use lower cost robots, have better reliability on the robots, and those sorts of things. I think automation is going to be critical moving forward past the COVID. We're going to need to reduce touch points. We're going to need to deal with, I think Steve mentioned yesterday, the possibility of 50% of the workforce being affected by this from a health standpoint. So automation is going to be extremely critical moving forward. And I hope you remember 3D printing and automation, they're really tied together. That they're one and the same from our customers' perspective. All right, so those are the four things that we wanted to talk about for specifics to operational enhancements with 3D printing. Advanced Tech is here to help you. We've got applications engineers here that can support you, and we can do that remotely. We can do that virtually, and we look forward to any opportunity to do that. Steve?
All right, thanks, Matt. Again, if you have any questions you'd like to submit, you can use the chat function and submit those now. One question I wanted to ask Matt, a lot of the talk has been around companies trying to help the national cause and trying to, promote with PPE, and a lot of companies or even high schools using their 3D printing capabilities to help in the cause. If a company has 3D printers, but they don't necessarily have strong engineering resources, how do you think they can get involved? I mean, I don't know that there's just files floating around the internet where they can download them and start producing product for the government or for hospitals. How can they get involved? How can they get connected to the right people?
It's a great question, Steve. That's kind of the beauty of the digital workflow. There's files available that have been approved by the FDA for emergency use. The designs have been approved for emergency use by the FDA and by NIH, and working with some folks from the VA on that as well. Those files are freely available. You can just download them. Right, I can provide that information. We've got some on the Stratasys website. That's one option. And then other folks are working on different things like ventilator splitters. There's been a lot about that in the news, as well as some other PPE type masks, reusable N95 replacement masks, those types of things. But that's getting the most visibility right now. But the big customers that are making these products in high volume manufacturing, the exciting thing is that they're tooling up quickly because of additive manufacturing in part. Additive manufacturing doesn't do everything, but it's part of the equation for the speed at which the company can turn over, increase production, work on the fly, and then distribute manufacturing to their plants. We have one customer who, a couple of years ago, they had a plant go down because of a typhoon, and they were able to bring that back in the States here within a couple of weeks compared to months that they would have traditionally taken. And most of the parts that touched their product were 3D printed. It was a kind of a game changer and an eye opener for the customer, but also for us. They taught us the importance of that.
So one more question for you, Matt. A lot of the products that our manufacturers are working on are regulated, are validated, they have controlled processes. So I know in our company, we often had in the prototyping stage and even during production, we were able to print things that enabled us to kind of, fix something, poke yoke something. But at the same time, if you're truly affecting the process, that may need to be something that's revalidated or, approved by your customer, the FDA. Do you have any recommendations? We're working with the state and federal government to try to ease up a little bit and allow companies to make some of those changes as needed. for our companies who aren't major OEMs that maybe have those direct connections and resources, any suggestions on how to navigate that if you're going to 3D print something on the fly to keep yourself operational or to take some labor out of something because you need to in the pandemic situation? How can we navigate that?
Yeah, so in highly regulated industries like healthcare, that's a big challenge. It's not only a material challenge; it's a process challenge. There's a lot of factors at play there. We're working with a lot of folks in the medical industry to figure out how we can improve processes or improve materials to help them meet those requirements. But in some cases, it's a risk mitigation effort. So we have lots of medical customers that use parts in clean room environments, but there's no real regulation around that right now. It's a pretty heavy gray area. So for the most part, when we're talking about tooling, manufacturing tooling, replacement parts for the manufacturing floor for machines that you can't get a part for anymore or something like that, not a whole lot of regulation there. Does it work? Is it going to work as a bridge or is it going to work as a complete replacement? As you said, making it pokey yoke, sometimes you can de-skill a tool by improving on an existing design and making that pokey yoke so that the operator can't mess it up. Those sorts of things, and there's less regulation around that. I think that's one of the reasons why maximizing 3D printing within manufacturing tooling applications has a lot more freedom because it's less regulated. Does that answer your question, Steve?
Yeah, thanks, Matt.
Yep.
All right, well, I think that concludes our webinar for today. If you do have any follow-up questions, feel free to reach out to one of the associations involved or directly to Advanced Tech. I want to thank Matt Habekost and Advanced Tech for putting together this webinar, and thanks for our partner associations. And I thank you for all attending and taking the time out of your day. We do have our next webinar will be next Wednesday, April 15th on employee morale in the workplace, put on by Michelle Neal of Enterprise Minnesota. I hope you can all make it to that. But otherwise, I hope you all take care, stay healthy. Hope your employees are staying healthy and wish you the best. Take care.
Thank you.